Hello, my name is Lee Young Kim. We will explore places which nature-based solutions are applied to solve environmental problems caused in watersheds due to excessive land use. The first place to visit is Gwangju Metropolitan City in Korea, where green rainwater infrastructure is applied to reduce environmental problems caused by high levels of impervious area in the city. And the second place is Jinan-gun, which is a case of a nature-based solution that reduces non-point pollution in rural areas to improve water quality of Yeongdam Lake. Lastly, Buldang New City in Cheonan is constructed with low-impact development to prevent environmental problems after development of the new city. I am now standing in front of the Gwangju City Hall. The Gwangju Metropolitan City Government has installed green stormwater infrastructures that manage rainwater through nature-based solutions. The place where I am standing now is a landscape painted with grass. However, this is not just a typical lawn. It has a different function aside from being a landscape area. A rainwater retention tank was installed beneath this space. This storage tank is a green stormwater infrastructure that collects and stores rainwater from the Gwangju City Hall, which can later be used as ecological water for landscapes during periods of dry days. This is another type of green stormwater infrastructure. This facility is called an ecological vegetated swale, wherein stormwater flows through an inlet then infiltrates into the ground. It also promotes the restoration of natural hydrology through evapotranspiration and the photosynthetic mechanisms performed by plants. These ecological waterways help maintain soil moisture, lower the ground temperature, and provide water for the surrounding plants. Since this facility provides a healthy environment for the surrounding vegetation, the carbon sequestration capabilities of plants are enhanced. The facility can also reduce the heat island effect through reduction of the ambient air temperature. This is the rooftop area of the Gwangju Metropolitan City Council building. A nature-based green stormwater infrastructure is also installed at this place, which is called green roof. Rooftop greening is a practice wherein plants are grown on the roof so that when it rains, the water can be stored in the soil. These plants on the roof also play an important role in the evapotranspiration process. One of the functions of green roof is to reduce energy use by lowering the temperature inside the building through the water storage function. In addition, the rooftop green space has the advantage of being used as a rest area and as a psychological cultural place. This is an example of a nature-based technology called rain garden. This rain garden facility allows water to infiltrate into the soil so that when it rains, the plants can utilize the water for growth by enhancing the level of groundwater and soil moisture. Creative layouts using various shapes and configurations can be incorporated into the design of rain garden facilities. The rain garden is a type of convergent green rainwater infrastructure facility that connects an infiltration trench and a bioretention. We are now at the Gwangju World Cup Stadium. NBS can be applied in various land use types within the city. NBS can be applied in various places, including residence, commercial district, park, and etc. The place I am currently standing is inside park that nature-based technologies are applied. Right now, we can see this rain garden that treats and stores the stormwater coming from that channel. This structure facilitates infiltration of water into the soil, whereas some portion of the water evaporates back into the atmosphere with the help of plants. The rain garden has many benefits that are carbon sequestration, promotion of effective rainwater circulation, non-point pollutant reduction, and aesthetic effects in the landscape areas. The long grass fields behind me are called vegetated swales. Vegetated swales are nature-based technologies that facilitate water circulation by allowing some storm water to infiltrate into the soil, while some other, a portion of water, can be returned to the atmosphere through evapotranspiration. These vegetated waterways capture nutrients such as nitrogen and phosphorus from the stormwater runoff. In turn, the nutrients can be contained in the soil and used by the plants. Furthermore, this facility is equipped with a transportation system that conveys the stormwater into the rain garden facility located in downstream area. Here, we can see a vegetated trench that receives stormwater runoff from an area overlaid with an impermeable pavement. These vegetated trenches collect stormwater runoff from pedestrian sidewalks, infiltrate it into the soil through porous media, and facilitate evapotranspiration through the help of plants. Vegetated trenches are also capable of non-point pollution reduction, carbon sequestration, and enhancement of landscape features. This is an ecological wetland that is constructed to improve the water quality in a water reservoir. This ecological wetlands are primarily used to treat non-point source pollution from the surrounding agricultural areas and other urban non-point pollution sources. The purified water from these wetlands flows into other reservoirs within the urban centers. These areas can also be considered as water-friendly places for residents. Constructed wetlands are widely used for water treatment, securing water resources, flood control, plant habitat, and educational purposes. These are built-in environment and provide ecosystem services by facilitating mass circulation and energy flow. Aside from the water purification function, regulating water services and cultural services are considered as very important functions of constructed wetlands. Treatment wetland is constructed to reduce concentration of non-point pollutants from upstream and improve water quality in downstream area. Generally, constructed wetlands can be classified as cell-type constructed wetlands or stream-type constructed wetlands. Cell-type constructed wetlands play a major role in inducing precipitation or sedimentation of particulates in water, whereas steam-type constructed wetlands enhance the collision of particulates in water. The wetland that you see behind me is a stream-type constructed wetland that serves as a particle collision-inducing facility between the two cell-type constructed wetlands. Various species of plants grow inside this stream-type constructed wetland. The plants inside the facility contribute physical and biological pollutant removal mechanisms within the system. The plants can reduce the flow of water to improve sedimentation of particulates and provide spaces wherein pollutants can be prevented and attached. On the other hand, the plants also help various microbial colonies to grow. The functions of plants in a constructed wetland are very important. Plants play a major role in removing nutrients such as nitrogen and phosphorus in water through photosynthesis. Therefore, this constructed wetland has high plant coverage in the inlet up to the midstream section, since the influent contains relatively high pollutant concentrations. However, we cannot see any plants in the pond behind me because the water here has already been treated. This area is intended for storing the treated water before it is discharged. This is a riparian ecobelt. This ecobelt is a constructed purification forest that utilizes the functions of natural components such as soil, media, soil microorganisms, and plants. It will serve as an additional treatment facility that purifies effluent discharged by water treatment facilities in small villages. Here, we can see the pond where the treated water from the ecobelt is stored. The water flowing into the ecobelt contains high concentration of nutrients such as nitrogen and phosphorus. These nutrients are mostly removed by soil media filtration, microbial degradation, and plant uptake. The treated water is stored in this pond before it is finally discharged. This ecobelt also performs carbon capture or carbon sequestration. While small wastewater treatment facilities in small villages produce considerable amount of carbon, the ecobelt absorbs the carbon. Therefore, the use of natural remediation technologies after wastewater treatment facilities is very important to achieve carbon neutrality. The ecobelt is a type of technology that utilizes natural treatment mechanisms. The soil media, soil microorganisms, and plants perform natural purification mechanisms. Agricultural discharges from surrounding areas flow into this ecobelt. As the polluted water flows through the soil layers of the ecobelt, the water is purified through the physical absorption of pollutants in soil and decomposition process by microorganisms. Finally, these plants also contribute to transformation and removal of pollutants that are released from soil layers. This soil contains diverse types of microorganisms. These microorganisms in soil play an important role in converting organic materials into inorganic materials that can be directly utilized by plants. Pollutants decomposed into organic substances are discharged from the soil to outside through photosynthesis of plants. The water flowing in this river is the purified and treated water discharged from the ecobelt. The ecobelt utilizes natural treatment mechanisms to remove pollutants in the water. Although plants cannot perform photosynthesis during autumn or winter seasons, water is still being treated in the ecobelt by the continuous microbial activities in soil. Constructed wetlands are composed of submerged plants, floating-leaved plants, and emerging plants. Submerged plants have their roots anchored at the bottom of the constructed wetlands, whereas floating plants are floated on the surface of the water. Floating-leaved plants are also rooted in the ground, but their leaves are revealed on surface of water. Emergent plants grow on the edge of the constructed wetlands and purifies water. Plants at the wetlands purify water, provide habitat for animal and fishes, and serve as carbon sink. Generally, constructed wetlands are created for the purpose of water purification. A number of constructed wetlands are installed to treat urban and agricultural wastewater. It is also used as treatment facility for non-point source pollutants. Constructed wetlands are frequently used as sites for environmental education as well, since these facilities are based on natural ecosystems. They are also used as cultural and leisure places for the residents living in the vicinity of the constructed wetlands. In general, urban drainage systems are made of concrete and are designed along with a straight waterway. However, nature-based solutions, like these vegetated swales, are made up of natural materials. They are also designed with natural slopes and topography that allow water to be collected and flow naturally. The stormwater generated from this park flows into these vegetated swales before it finally reaches the ecological ponds. A check dam is placed along the course of the facility to prevent the immediate discharge of water from the vegetated channels into the ecological pond. These check dams can regulate the flow of water and provide ample hydraulic residence time. This area is an ecological pond. The stormwater generated in this park will flow along the vegetated waterway before it is finally stored in this ecological pond. Rainwater that enters the ecological pond penetrates into the soil, and some portion of water evaporate into the air through plants. Ecological waterways are commonly referred to as constructed wetlands. Constructed wetlands filled with water are called wet wetlands, whereas those without water are known as dry wetlands. Right now, we are seeing an example of a dry wetland. As you can see, this structure was made up of natural materials and structures. It was designed in such a way that it facilitates natural flow of water. The pollutants in stormwater can also be filtered as the water infiltrates through the soil. In addition, we usually build dry wetlands in urban areas so that we can prevent the proliferation of mosquitoes during the summer season. Urban development increases the percentage of impervious areas, like roads and sidewalks. Increasing the area of impervious surfaces can lead to various urban environmental problems, such as distorted water cycle, heat island phenomenon, non-point source pollution, and urban flooding. We are walking on an infiltration trench. It is a technology that promotes water circulation. Stormwater from the surrounding area is collected in this facility and slowly infiltrates into the ground. Although we can only see gravel layer on the surface, there are porous soil layers below that have high permeability and promote infiltration rates. During rainy days, stormwater will be directed and stored in pore spaces, while some amount are infiltrated into the ground. Surrounding vegetation will help the other portion of stormwater return to the air through evapotranspiration. This type of infiltration facility also provides ecosystem services and reduce influent pollutant concentrations with soil microorganisms that grow in media. There are a lot of small and distributed, low-impact development facilities installed in this park. The stormwater runoff generated in this area is redirected to vegetated swales, permeable pavements, and infiltration trenches before finally being discharged into a medium-sized constructed wetland. Constructed wetlands can be comprised of surface flow constructed wetlands and subsurface flow constructed wetlands. In general, subsurface flow constructed wetlands are more preferable for urban areas since they do not emit odor nor provide breeding grounds for mosquitoes. These constructed wetlands also provide various ecosystem services. The plants inside the wetlands provide habitat for diverse animals or organisms. This area can also be utilized by the residents as a recreational space. Various types of pollutants, such as oil and grease, heavy metals, and hydrocarbons accumulate on the roadsides due to high rates of vehicular traffic and impervious areas. These pollutants, mixed with stormwater, then flows into the urban street green belt space. Within these green spaces, the pollutants are purified through microbial degradation and plant uptake. Additionally, the stormwater that has passed through the street green belt will undergo another process of treatment in the permeable block zone. Finally, the water that has been treated by the permeable blocks will be directed here in the infiltration trench. This infiltration trench provides various water circulation functions such as retention, infiltration, and evapotranspiration. Soil microorganisms living in the storage spaces within the facility also help reduce pollutant concentrations. We are now at the lowest area of Puldang New Town. All stormwater treated by the small and distributed low-impact development facilities installed within Puldang New Town are discharged and collected in this location. Places like this are sometimes referred to as retention basins or constructed wetlands. The functions of these constructed wetlands may vary. A primarily function of constructed wetland is taking a role as a treatment facility, but it can also relieve flood in downstream areas by storing floodwater and discharging it slowly. It is also capable of sequestrating the CO2 generated from the surrounding urban area. The stormwater from the whole city is collected in this constructed wetland. The stormwater that enters this facility contains various pollutants at first, but with the contribution of microbial degradation in soil and the plants placed on this wetland, such as reed, silvergrass, and cattail, the water will go under the process of purification. A large amount of stormwater that entered into this facility can either be stored, infiltrated into the ground, or released back into the atmosphere through evapotranspiration. The excess stormwater will then be discharged into the river through this channel. Constructed wetlands greatly contribute to water quality improvement since they treat stormwater before it is discharged to nearby rivers. LID facilities with nature-based functions installed throughout the city can provide a multitude of ecosystem benefits. It provides socio-cultural and eco-education services to urban residents, while it also leads a major role in solving urban problems, such as urban heat island effect, non-point source pollution, and occurrence of sinkholes. Adopting nature-based solutions will greatly contribute to the formation of a city where people and nature coexist.